Hola, querida comunidad de YouTube. Bienvenidos una vez más a nuestro canal, donde las historias más extraordinarias de ingenio humano y arquitectura innovadora cobran vida ante vuestros ojos. Soy vuestro narrador de confianza y hoy tengo preparada para vosotros una historia que os dejará reflexionando sobre el poder de la innovación constructiva y la importancia de no subestimar las ideas que desafían las normas tradicionales. ¿Habéis experimentado alguna vez esa sensación de tener una visión arquitectónica revolucionaria mientras todos a vuestro alrededor la consideran completamente absurda? ¿Habéis sentido la frustración de ser ridiculizados por construir algo que va contra todas las convenciones sobre diseño residencial? La historia que estáis a punto de escuchar trata exactamente de eso. Es la narrativa extraordinaria de un hombre visionario que desafió siglos de tradición arquitectónica con una construcción tan insólita como efectiva, enfrentando las burlas de toda su comunidad hasta que la realidad demostró la genialidad de su diseño aparentemente disparatado. Esta es una historia real que ocurrió en las montañas de Cáceres, España, donde los inviernos pueden ser brutales y donde una mente creativa puede transformar principios arquitectónicos fundamentales para crear soluciones que superan a la construcción convencional. Nuestro protagonista desafió todas las normas sobre vivienda rural con una técnica tan ingeniosa como controvertida que cambiaría para siempre la forma en que su comunidad entendía la relación entre forma arquitectónica y eficiencia térmica. Antes de sumergirnos en esta increíble historia de visión y perseverancia, no olvidéis darle like a este vídeo si queréis más contenido como este. Suscribíos al canal y activad la campanita de notificaciones para no perderos ninguna de nuestras fascinantes historias. Y por favor, decidme en los comentarios desde qué país y ciudad nos estáis viendo. Me encanta conocer a nuestra maravillosa audiencia global. Sin más demora, acompañadme en este viaje extraordinario donde descubriremos cómo una torre de piedra aparentemente ridícula puede mantener un dormitorio 30 grados más cálido que el exterior. Párrafo 1. Abundio. Morales. Herrero había vivido toda su vida en las agrestes montañas de la Sierra de Gredos, en la provincia de Cáceres, donde las temperaturas invernales podían descender hasta 15 grados centígrados, y donde cada familia dependía de arquitectura tradicional que había sido refinada durante siglos para sobrevivir a condiciones climáticas que desafiaban constantemente la capacidad humana para mantener calor y comodidad durante los largos meses de frío implacable que caracterizaban la vida en altitudes elevadas del oeste peninsular. A sus 59 años, Abundio era conocido en toda la comarca como el albañil filósofo, un apodo que había ganado no solo por su habilidad excepcional en construcción con piedra, sino también por su tendencia obsesiva a cuestionar principios arquitectónicos fundamentales que otros aceptaban sin cuestionamiento, desarrollando teorías poco convencionales sobre cómo la forma de los edificios afectaba su capacidad para capturar, retener y distribuir calor de maneras que la construcción tradicional no aprovechaba óptimamente. Su propiedad, heredada de su abuelo paterno, consistía en 3 hectáreas de terreno rocoso ubicadas en una ladera expuesta, donde había vivido durante décadas en una casa de piedra tradicional que, a pesar de gruesas paredes y construcción sólida, nunca había proporcionado el nivel de confort térmico que él creía debería ser posible, utilizando técnicas de construcción que incorporaran más efectivamente principios de retención de calor que había observado en estructuras naturales como cuevas, formaciones rocosas, incluso madrigueras de animales que parecían mantener temperaturas estables independientemente de condiciones climáticas exteriores. Durante décadas de trabajo como maestro albañil, especializado en construcción con piedra local, Abundio había desarrollado una comprensión intuitiva pero profunda de cómo diferentes formas geométricas y configuraciones espaciales afectaban el movimiento de aire, la distribución de calor y la estabilidad térmica en espacios interiores, conocimiento que había aplicado en múltiples proyectos de construcción y renovación para clientes que valoraban su habilidad técnica pero que frecuentemente rechazaban sus sugerencias más innovadoras sobre modificaciones arquitectónicas que podrían mejorar dramáticamente la eficiencia energética de sus hogares. Sus observaciones más significativas se relacionaban con cómo estructuras verticales, especialmente aquellas con formas cilíndricas o cónicas, parecían crear patrones de circulación de aire que favorecían la retención de calor en niveles superiores, mientras mantenían temperaturas más frescas en áreas inferiores, efecto que sugería posibilidades para diseños residenciales que podrían aprovechar convección natural para crear zonificación térmica que maximizara confort humano, utilizando mínima energía externa para calefacción o refrigeración. Sin embargo, sus ideas sobre arquitectura termalmente inteligente habían sido consistentemente descartadas por clientes y colegas que preferían métodos de construcción tradicionales que, aunque probados por el tiempo, no incorporaban innovaciones que podrían mejorar significativamente la habitabilidad y eficiencia energética de viviendas rurales. La inspiración específica para su proyecto más ambicioso surgió durante una tarde de invierno de enero de 2019, cuando estaba reparando la chimenea de su casa tradicional, y notó cómo el humo ascendía en patrones espirales que sugerían movimientos complejos de aire caliente que podrían ser aprovechados arquitectónicamente si una estructura pudiera capturar y dirigir estos flujos térmicos de manera más efectiva que las configuraciones rectangulares convencionales que caracterizaban prácticamente toda la arquitectura residencial de su región. Abundio había comenzado a imaginar una torre de calor que funcionaría como una chimenea gigante invertida, utilizando principios de convección para crear corrientes ascendentes de aire caliente que se acumularían en niveles superiores, donde él podría ubicar espacios de vida que se beneficiarían de temperaturas consistentemente más altas que aquellas posibles en construcciones horizontales tradicionales, que no aprovechaban efectivamente la tendencia natural del aire caliente a elevarse y concentrarse. De espacios verticalmente orientados, la visión que desarrolló era radical en su departure de convenciones arquitectónicas. En lugar de construir hacia el exterior como las casas tradicionales, construiría hacia arriba, creando una estructura vertical de piedra que funcionaría como un sistema de calefacción pasivo-masivo que utilizaría únicamente principios físicos naturales para mantener temperaturas habitables sin depender de combustibles externos o sistemas mecánicos complejos que podrían fallar durante emergencias o resultar prohibitivamente costosos para su presupuesto limitado de artesano rural. Cuando Abundio compartió esta visión revolucionaria con su esposa Esperanza y sus vecinos del pueblo de Tornavacas, se encontró con reacciones que variaban desde preocupación genuina por su estabilidad mental hasta burlas abiertas sobre lo que percibían como la idea más ridícula que había tenido en una carrera, llena de sugerencias arquitectónicas poco convencionales que habían entretenido pero raramente convencido a people de su comunidad conservadora. Esperanza expresó temores específicos sobre la seguridad estructural de construir tan alto, utilizando técnicas de construcción tradicional en un terreno que podría no ser adecuado para soportar el peso de una estructura vertical masiva, mientras que también se preocupaba por el costo del proyecto que obviamente requeriría cantidades enormes de piedra y meses de trabajo intensivo que representarían inversión de tiempo y dinero que su familia podía necesitar para other priorities. Los vecinos del pueblo comenzaron a referirse jocosamente al proyecto propuesto como la Torre de Babel de Abundio o el Faro Montañés, comentarios que reflejaban tanto su incomprensión del concepto técnico como su escepticismo fundamental sobre si una idea tan alejada de métodos arquitectónicos probados podría realmente funcionar mejor que casas tradicionales que habían servido adecuadamente a familias de la región durante generaciones. Sin embargo, Abundio, armado con décadas de experiencia práctica en construcción con piedra y una convicción profunda sobre la validez de principios térmicos que había observado en estructuras naturales, decidió proceder con su experimento, convencido de que la aplicación cuidadosa de técnicas de albañilería tradicionales a una forma arquitectónica innovadora produciría una vivienda que superaría dramáticamente cualquier cosa que pudiera lograr mediante renovación de su casa existente o construcción de una nueva residencia utilizando métodos convencionales. Párrafo 2. La fase de diseño y planificación se extendió durante 8 meses intensivos, desde febrero hasta septiembre de 2019. Durante los cuales Abundio transformó su comprensión empírica de construcción con piedra en un plan arquitectónico detallado que combinaba técnicas de albañilería tradicional con innovaciones estructurales que permitirían construcción segura de una torre residencial de 18 metros de altura utilizando únicamente piedra local, mortero de cal y herramientas manuales que había utilizado durante décadas en proyectos de construcción convencional. Su diseño final especificaba una estructura cilíndrica con paredes de 80 centímetros de grosor en la base que se reducirían gradualmente a 50 centímetros en niveles superiores, proporcionando estabilidad estructural masiva, mientras minimizando el peso total que tendría que ser soportado por los cimientos que él excavaría y construiría personalmente, utilizando técnicas que había perfeccionado durante años de trabajo en foundations para casas tradicional en terreno montañoso similar. El interior de la torre estaría dividido en 4 niveles principales. Un almacén en el nivel base que aprovecharía temperaturas frescas y estables para preservación de alimentos. Un nivel de vida general que incluiría cocina y área social. Un dormitorio principal en el tercer nivel que se beneficiaría de temperaturas óptimas created por convección natural. Y un level superior que funcionaría como observatory y área de almacenamiento que también serviría para monitorear y ajustar ventilation que optimizaría circulation de air throughout la entire structure. Los cálculos estructurales que Abundio realizó para asegurar estabilidad de su tower fueron remarcablemente sophisticated para un proyecto desarrollado sin formal engineering education, incorporando principles de distribution de weight, stress analysis y foundation design que había learned a través de experience, pero que aplicó sistemáticamente para create una structure que could withstand not only su own considerable weight, sino también forces generated por wind loads y thermal expansion durante temperature cycles que could affect stability over long periods de continuous operation. He had calculated que aproximadamente 400 tons de stone would be required para complete construction, material que he could extract largely desde quarries and su own property combined con stone, purchased desde local suppliers cuando specific types de rock were needed para particular applications como lintels, cornerstone y foundation blocks que required superior strength characteristics. El design también incorporated innovative features como internal air shafts que would create convection currents que would draw warm air upward mientras allowing cool air entrada en lower levels, creating circulation patterns que would maintain optimal temperature distribution throughout lay tower, sin requiring external energy sources, a mechanical systems que might be unreliable durante extreme weather conditions que frequently isolated su mountainous region durante winter months. La preparation para construction required developing techniques para moving large quantities de stone up increasingly steep slopes como la tower grew taller, problema logístico que Abundio solved a través de design de ramp systems y hoisting mechanisms, utilizando traditional carpentry techniques, combined con creative applications de pulleys y levers que would allow him a continue construction progress without requiring expensive mechanical equipment or outside assistance que would dramatically increase project costs beyond what his limited budget could support. He had also designed scaffolding systems que would provide safe working platforms durante different phases de construction, while ensuring que his working methods would not compromise structural integrity de partially completed sections, que would need a support increasing loads, como additional levels were added above them. Every aspect of planning phase was documented meticulously, and detailed drawings, written specifications que would guide daily construction decisions, y ensure que work proceeded systematically toward completion, the structure que would function según his thermal efficiency theories, while meeting safety standards que would protect his family durante decades de anticipated occupancy. Durante este periodo de intensive planning, Reactions desde su community evolved desde casual ridicule toward serious concern cuando neighbors began to understand la scale y complexity the project que Abundio was developing, realizing que he was committing a construcción que would dramatically alter landscape de su mountainous area y que represented financial y time investment que seemed totally disproportionate a potential benefits que most people could imagine resulting desde such an unconventional approach a residential architecture. Esperanza had begun documenting photographic evidence de every stage de su planning process, maintaining detailed records. The technical decisions y design modifications que would eventually serve como comprehensive guide para anyone interested in understanding how traditional masonry techniques could be applied to innovative architectural forms que departed dramatically desde conventional approaches of residential construction. However, algunas neighbors had begun expressing concerns a municipal authorities sobre possible building code violations or safety issues que might result desde construction de such an unusual structure without professional architectural or engineering oversight que would normally be required para projects de comparable scope y complexity. Párrafo 3. La construcción de la torre comenzó durante la primera semana de octubre de 2019, cuando las condiciones climáticas otoñales proporcionaban temperaturas ideales para trabajo con mortero de cal y manipulación de piedras pesadas que requerirían meses de labor física intensiva bajo condiciones que incluían lluvia ocasional, viento fuerte y las primeras heladas que presagiaban la llegada del invierno, durante el cual Abundio esperaba completar al menos los primeros 3 niveles de su estructura para poder comenzar las pruebas térmicas que determinarían si sus teorías sobre convección vertical se traducirían en beneficios prácticos de calefacción, que justificarían la inversión masiva de tiempo, dinero y esfuerzo físico que el proyecto obviamente demandaba. El proceso de excavación de cimientos requirió 3 semanas de trabajo manual en suelo rocoso que tenía que ser removido utilizando herramientas manuales, técnicas de voladura controlada, con pequeñas cantidades de explosivos, que Abundio había aprendido a utilizar durante proyectos anteriores de construcción, en terreno montañoso, y métodos de remoción de rocas que habían sido perfeccionados durante generaciones de construcción rural en la región donde bedrock frecuentemente interfería con proyectos de excavación que requerían foundations profundas para estabilidad estructural a largo plazo. La colocación de las primeras hileras de piedra fundacional requirió precisión excepcional para establecer la geometría circular perfecta que sería esencial para estabilidad estructural de toda la torre, trabajo que demandaba uso de compases improvisados, técnicas de measurement que Abundio había desarrollado durante décadas de construcción con piedra y atención meticulosa a leveling que aseguraría que cada successive hilera de stones would be positioned correctamente para create gradual reduction in wall thickness que he had calculated para optimize both structural stability y thermal performance de completed structure. Cada stone tenía que be selected individually desde piles de material que he had accumulated durant months de quarrying operations, then shaped precisely using traditional stone cutting techniques, que required skills que he had developed durante toda una lifetime de specialized masonry work, que had established his reputation como premier stone craftsman en toda la región mountainous, donde few people possessed necessary expertise para undertaking projects de such technical complexity y architectural ambition. Durante las first 6 weeks de construction, Abundio had begun a observe preliminary evidence que his theories about vertical air circulation were valid even in partially completed structure, noticing que temperatures dentro de enclosed spaces created por foundation walls y first few rows de stones were noticeably more stable que ambient temperatures outside, suggesting que a complete tower might indeed create thermal effects que were substantially more pronounced que what he was observing durante initial phases to construction when only small enclosed volumes existed, a trappy circulate air according a principles de convection que he had theorized would govern thermal performance to finished structure. Esperanza had begun documenting these early temperature differences using multiple thermometers placed strategicamente throughout construction site a monitor how different sections the growing structure affected local temperature patterns, observations que would provide valuable data para optimizing ventilation y interior layouts durante later phases de construction, cuando decisions about window placement, door orientations, internal air circulation systems would determine how effectively completed tower would function, como passive heating system que could maintain comfortable living temperatures durante harsh winter conditions could characterize climate in su elevated mountain location. Las reactions desde local community durante construction phase intensified dramatically, como la tower grew taller y became increasingly visible desde long distances throughout valle que surrounded Abundio's property, transforming what had initially been perceived como somewhat eccentric private project into highly conspicuous public spectacle, que generated opinions ranging desde grudging admiration para his technical skill y determination, hasta serious concerns about safety implications y potential impact and property values to neighboring households que had not anticipated living adjacent to such unusual architectural experiment. Don Carlos Méndez, el alcalde de Tornavacas, organized inspection visits que included municipal building inspector y representative desde provincial construction authorities que needed to evaluate whether project complied con applicable building codes y safety regulations, though they encountered difficulty applying standard residential construction standards, a structure que was unprecedented on su form y function y que therefore required evaluation using criteria que had never been developed para such innovative applications to traditional construction techniques e unconventional architectural purposes. Párrafo 4. El primer invierno de construcción parcial proporcionó evidencia preliminary but convincing que las teorías térmicas de Abundio tenían mérito substancial, cuando temperaturas dentro de niveles partially completed de la tower remained consistently 5 degrees warmer que ambient exterior conditions, incluso cuando only foundation level y first floor were enclosed y habitable. Performance que suggested que complete structure might achieve even more dramatic temperature differentials que would make comfortable year-round habitation possible, utilizando minimal external heat sources durante even harshest winter weather que characterized su mountain environment. Durante particularly cold snap en enero 2020, cuando exterior temperatures dropped a 12 grados centígrados para múltiple consecutive days, interior temperature and first floor de partially completed tower never descended below 2 grados centígrados, a pesar de fact que no heating was being provided except para occasional small fires, que Abundio lit para comfort durante construction work, demonstrating que thermal mass stone walls combined con natural air circulation created per tower's vertical geometry was indeed providing significant insulation effects que exceeded performance to most traditional residential construction in similar climatic conditions. Construction de second y third floors durante spring de 2020 revealed additional thermal effects que confirmed Abundio's theories about vertical temperature stratification, con upper levels maintaining consistently higher temperatures que lower areas even durante cool weather periods cuando little solar heating was available, a warm structura general. By Junio 2020, cuando all major structural work was completed y interior spaces were ready para occupancy, temperature measurements conducted throughout different levels, the tower showed clear evidence de thermal zonification que created ideal conditions para habitation in upper floors, donde bedroom areas would benefit desde naturally. Warmer conditions meant lower levels remained cooler y more suitable para food storage, workshops, y other activities que benefited desde moderate temperatures que were naturally maintained año-round without requiring energy input para heating o cooling que would be necessary in conventional residential structures. La completion de tower construction coincided con arrival de engineers desde Universidad de Extremadura que had heard about project a través de professional networks y wanted to study scientifically las thermal dynamics que were creating such remarkable temperature control and structure que utilized no electrical systems, no mechanical heating or cooling equipment, y no external energy sources beyond passive solar heating que was available naturally in su sunny mountain location. Dr. Rosa Martinez, specialist in passive solar architecture, conducted extensive testing durante summer months using professional monitoring equipment, who confirmed the tower was achieving thermal performance, who exceeded most commercial passive heating systems, mientras using only traditional stone construction techniques combined con innovative architectural geometry, que maximized natural air circulation I thermal mass effects, que traditional rectangular buildings could not duplicate regardless the insulation quality of heating system sophistication. Los results de professional analysis were remarkable. Durante peak summer conditions, cuando exterior temperatures reached 38 grados centígrados, interior temperatures in bedroom level remained stable between 22 and 25 grados centígrados without requiring any cooling systems, whilst durante winter testing cuando exterior temperatures dropped a 10 grados centígrados, same bedroom areas maintained temperatures de 18 to 21 grados centígrados, using only small amounts to wood burned in fireplace durante evening hours, que provided sufficient heat input, maintained comfortable conditions throughout entire night without requiring additional fuel or attention durante sleeping hours. Señor Morales has achieved through practical innovation what formal passive solar research has been working toward para years, declared Dr. Martinez durante presentación de her findings at academic conference focused on sustainable architecture. His tower demonstrates how traditional building techniques can be applied to innovative forms to achieve superior thermal performance compared to most commercial energy-efficient housing systems whilst using only locally available materials. Why traditional craftsmanship skills. Párrafo 5. La primera noche que Abundio y Esperanza pasaron en su completed bedroom durante enero de 2021 marcó el triunfo definitivo de su architectural experiment. Cuando exterior temperaturas de 13 grados centígrados, produce de interior temperaturas de 17 grados centígrados en a sleeping area sin requiring any heating beyond small fire que had been lit durante afternoon y allowed to extinguish completely before bedtime, demonstrating que thermal mass I convection effects were maintaining comfortable habitation conditions durante precisely those extreme cold conditions que had motivated original project cuando Abundio became frustrated con inadequate heating performance de traditional house durante harsh winter periods que required constant attention. A fuel consumption y fire maintenance que disrupted sleep y created ongoing concerns about heating costs que consumed major portion to limited household budget. Esperanza, que had initially been skeptical about abandoning traditional house para such unconventional living arrangement, discovered que bedroom area remained consistently comfortable throughout night. A morning warming periods required significantly less heating fuel because she had experienced durant decades. The living in conventional stone house could required large amounts of firewood and maintain basic habitability durant winter months, when the temperatures frequently remained below freezing para weeks at time ensue. Exposed. Mountain location. Durante coldest period de winter 2020-2021, cuando temperatures dropped a record low de 18 grados centígrados y remained below 10 para 10 consecutive days, tower bedroom maintained temperatures between 15 to 19 grados centígrados throughout entire cold snap, whilst many conventional houses in area experienced heating system failures, frozen pipes. The interior temperatures que dropped to levels que forced temporary evacuation to elderly residents que could not safely remain in inadequately heated homes durant extreme weather emergency, que tested limits to all residential heating systems, regardless to fuel type or system sophistication. Abundio's tower not only maintained comfortable temperatures throughout crisis, but actually provided temporary shelter para two elderly neighbors que had lost heating cuando their conventional systems failed durant power outage que affected most de valley durant worst period de cold snap, demonstrating que innovative architecture had created not only comfortable family residence, sino también community resource que could provide emergency housing durant extreme weather events que were becoming more frequent y severe debido a climate change affecting traditional weather patterns in mountainous regions. Recognition de success de Abundio's project had begun spreading throughout region cuando news de tower's exceptional thermal performance reached other communities and families struggled with similar heating problems durant winters que were becoming increasingly expensive debido a rising fuel costs y increasingly unreliable. debido a infrastructure vulnerabilities que left rural communities vulnerable to supply disruptions during extreme weather periods, cuando heating was most critically needed. Visitors began arriving desde distances de más que 50 kilometers a observe firsthand la tower que was maintaining comfortable interior conditions using minimal energy inputs whilst providing living space que was superior and comfort a most conventional homes regardless de heating system cost or sophistication, transforming Abundio desde local eccentric towards recognized innovator. He had solved practical problems that affected rural communities throughout mountainous regions to western Spain, onde conventional architecture was proving increasingly inadequate para maintaining comfortable while affordable habitation during winters. He were testing traditional approaches a residential heating. Municipal officials desde Tornavacas had begun receiving inquiries desde other communities, interested in learning about construction techniques that had produced such remarkable results. Y alcalde Don Carlos Méndez organized formal presentation, durante cual Abundio explained his design principles y construction methods, a audience que included mayors desde 6 neighboring municipalities, representatives desde Provincial Housing Authority, y journalists desde regional newspapers que were covering growing interest in sustainable architecture solutions que could provide affordable alternatives, a conventional residential construction, que was becoming increasingly expensive para rural families. He could not afford commercial heating systems. He provided adequate comfort during severe winter conditions. Abundio has demonstrated that innovation in sustainable housing doesn't require expensive technology or university education, declared alcalde durante presentation. His tower proves that traditional skills combined con creative thinking can produce housing solutions that work better than anything available commercially, whilst using only materials y techniques que are available in our local communities. Párrafo 6. Durante el segundo year de occupancy, desde octubre 2021 hasta septiembre 2022, Abundio documented systematically la thermal performance de su tower bajo complete range de seasonal conditions, creating comprehensive record the energy consumption, comfort levels, y maintenance requirements que would establish definitively whether innovative architecture provided sustained benefits, who justified initial investment to time, materials, the effort que had been required para construct such unusual residential structure. His detailed logs revealed que annual firewood consumption para heating entire tower was approximately 40% the amount que had been required. A heat traditional house a comparable comfort levels, whilst achieving superior temperature stability, que eliminated cold morning warm-up periods, nighttime heating maintenance, seasonal comfort variations que had characterized families' previous living experience durant decades in conventional stone house que required constant attention, a heating systems y seasonal fuel management que consumed substantial time y money each year durant extended winter periods que characterized climate and su mountain location. Más significant que quantifiable energy savings was dramatic improvement in quality the daily life, que resulted desde living in a space que maintained comfortable temperatures automatically without requiring constant monitoring, fuel management, o system maintenance que had previously dominated winter routines cuando families' daily schedule revolved around heating needs que required early morning firelighting, regular fuel addition throughout day, I careful banking de fires durant night a ensure adequate warmth para sleeping comfort, without wasteful overheating que would consume unnecessary fuel durant periods, cuando economic resources were most constrained by seasonal employment patterns, que characterized rural mountain economies. During winter months typically meant reduced income, combined con increased heating costs, que strained family budgets durante coldest periods cuando heating was most essential, pero most expensive to provide through conventional methods. Recognition the accomplishment had expanded regionally cuando Universidad de Salamanca invited Abundio a participate in an international conference sobre vernacular architecture innovations donde su presentation sobre vertical thermal architecture, traditional techniques applied, a innovative forms, was received enthusiastically by audience de architects, engineers, y de housing specialists desde throughout Europe, quien recognized que his practical achievements represented breakthrough in low-cost, sustainable housing design que could be replicated in rural communities, donde conventional energy-efficient housing was economically inaccessible, pero donde local stone y traditional building skills provided resources para implementing similar projects adapted a local conditions y cultural preferences que varied throughout different mountainous regions, donde climate challenges were similar, pero available materials y traditional techniques differed according a local geological y cultural characteristics. Durante conference presentation, Abundio emphasized que most important aspect de his innovation was demonstration, que effective solutions frequently emerged desde practical problem solving by individuals quien understood intimately la conditions y constraints que characterized their local environments, y que formal architectural education, whilst valuable, was not prerequisite para developing housing innovations que could dramatically improve habitability whilst using only materials and techniques que were available locally. A rural communities que needed affordable alternatives, expensive commercial systems que might not be appropriate para their specific climatic challenges or economic circumstances. His approach had been to observe carefully how natural thermal processes worked in stone structures, then apply traditional construction skills, architectural forms que would optimize those natural processes para human habitation, methodology que could be adapted for other rural communities facing similar challenges, regardless to their specific local materials or traditional building techniques. Párrafo 7. El tercer invierno de ocupación, durante 2022-2023, proporcionó validación final cuando temperatures reached extreme lows de 21 grados centígrados durante January cold snap, que established new record para región y que tested heating systems throughout area a breaking points, with many conventional systems failing completely. Durant week-long period de extreme cold, que required emergency heating centers to be established and municipal buildings para residents que could not maintain safe temperatures in sus homes using normal heating methods. Durante same period de unprecedented cold, Abundio's tower maintained bedroom temperatures between 16-20 grados centígrados, whilst using only 30% more firewood que normal winter consumption. Performance que demonstrated que innovative architecture provided not only improved daily comfort, sino también superior emergency resilience durante extreme weather events que were challenging all conventional heating approaches regardless to fuel type, system cost, or installation sophistication that characterized most residential heating systems in area. Performance data collected durant 3 complete years. The occupancy confirmed que tower achieved thermal efficiency equivalent to most sophisticated commercial passive heating systems whilst using only traditional materials y construction techniques que could be replicated por skilled craftsmen working with locally available stone y basic construction tools que were accessible a rural communities. Throughout mountainous regions de Spain y other countries con similar climatic conditions y traditional building material availability. Economic analysis revealed que construction costs had been recovered a través de heating fuel savings durant second year de occupancy, with subsequent years providing net positive economic return, que would continue throughout anticipated useful life de structure, que was built using techniques designed para durability, measured in decades rather, que years typical para conventional residential construction que required frequent maintenance y periodic replacement de heating systems y insulation que deteriorated under stress de repeated temperature cycling or moisture exposure que characterized harsh mountain climates. International attention culminated cuando United Nations Human Settlements Program featured Abundio's Tower and Global Report sobre Indigenous Innovations in Sustainable Housing, recognizing que his work demonstrated how traditional building knowledge could be enhanced a través de systematic experimentation, create solutions que were relevant para contemporary challenges related to climate change, energy security, y affordable housing durant era cuando conventional building methods were becoming increasingly expensive y environmentally problematic para communities que needed effective alternatives. Energy-intensive commercial systems que might not be available or affordable in many parts of the world, and similar housing challenges existed, pero donde different traditional materials y techniques could be adapted, usando same principles que Abundio had applied a his specific local conditions y cultural context. Como recognition de su work expanded internationally, Abundio established informal apprenticeship program onde individuals desde other communities could visit su property, learn hands-on construction techniques durant multi-week stays, que provided comprehensive training in stone masonry, thermal design principles, a project planning methods que would enable participants to implement similar projects adapted to their own local conditions whilst contributing a ongoing development de techniques a través de experimental projects que tested variations de basic approach under different climatic and material conditions. My goal was always simply a build house que would keep my family warm without bankrupting us durant winter, Abundio explained durante interviews with international visitors. But if techniques I developed para solve mi own problem can help other people create better housing in sus own communities, usando whatever materials or skills they have available, then sharing that knowledge freely as responsibility que I accept with pride. Párrafo 8. Para cuarto aniversario de Tower completion en octubre de 2023, Abundio had documented cumulative benefits que included total heating fuel savings equivalent to approximately 3,200 euros over 4 years, environmental benefits equivalent to preventing release to several tons of carbon dioxide que would have resulted these conventional heating methods, y social benefits que included enhanced emergency preparedness durante extreme weather, inspiration para other innovative building projects throughout region, y establishment de su property, como informal education center, donde people desde throughout Spain y other European countries could study firsthand how traditional building techniques could be applied to architectural forms que achieved superior performance compared to conventional residential construction methods regardless to budget or technology availability. Recognition, the importance de sus contributions, a sustainable architecture had reached institutional levels cuando Junta de Extremadura commissioned comprehensive study the economic and environmental impacts to promoting wider adoption to building methods based on principle que Abundio had demonstrated so successfully, recognizing que his innovations could contribute significantly to regional goals para carbon reduction whilst improving housing affordability para rural communities que often struggled con high energy costs y inadequate heating durant winter months, que could compromise health and economic security to vulnerable populations, including elderly residents and families con limited economic resources que needed effective alternatives, the expensive commercial heating systems que were beyond reach to many rural households. Abundio had begun development de standardized building plans que would adapt his basic principles at different local materials and construction traditions, creating resources que could guide implementation to similar projects and regions onde local stone types, traditional building techniques, o climatic conditions differed, desde those que characterized his own location, pero on same thermal principles could be applied using whatever materials y skills were available locally. Communities interested in developing affordable sustainable housing alternatives que utilized local resources y traditional knowledge rather que depending on expensive commercial systems que might not be appropriate para their specific circumstances or budget constraints. Educational materials included detailed construction guides, thermal performance calculations, adapted para different climatic zones, y troubleshooting information que would help other builders avoid problems, and optimize performance de structures adapted to their specific conditions and needs. Durante anniversary celebration attended por representatives desde universities, government agencies, and international development organizations que had studied his work and promoted similar approaches in other communities throughout Europe and developing countries onde housing challenges were particularly severe para rural populations. Abundio reflected in transformation que had occurred depuis su initial frustration con inadequate heating in traditional house toward recognition como innovator whose practical achievements had demonstrated viability de approaches que could be replicated throughout communities que needed affordable alternatives, conventional construction methods que were failing to provide adequate housing para Increasingly challenging climatic conditions, economic constraints que characterize contemporary rural life in mountainous regions worldwide. Traditional approaches were proving insufficient para maintaining habitability, economic sustainability, durante extreme weather events que were becoming more frequent, severe due to global climate change. Párrafo 9. Durante 2024, cuando global discussions about climate adaptation y sustainable housing had intensified due a increasing frequency, the extreme weather events y rising energy costs que were affecting vulnerable communities worldwide, Abundio's Tower was featured in multiple international publications y documentary films que highlighted innovative approaches. A housing resilience que could be implemented using traditional materials y techniques combined con creative adaptation de natural thermal processes que provided superior performance. A conventional construction methods whilst remaining accessible, a community's con limited. Resources pero abundant traditional building knowledge y local materials que could be utilized effectively when applied, architectural forms optimized para thermal efficiency rather que aesthetic conformity, con conventional residential designs que prioritized appearance over performance in challenging climatic conditions. Collaboration con UNESCO resulted in establishment the formal documentation project que would preserve detailed records de construction techniques, thermal design principles, y adaptation methodologies, que could guide similar projects in different cultural y climatic contexts throughout regions on the traditional building knowledge existed, pero needed enhancement a través de systematic application de thermal efficiency principles que Abundio had developed a través de practical experimentation combined con deep understanding de traditional stone construction techniques que provided foundation para innovations que enhanced rather que replaced traditional knowledge with approaches que utilized local resources more effectively, whilst achieving superior performance compared to conventional methods que had evolved durante different historical periods cuando energy efficiency was less critical para economic sustainability y environmental protection. Educational impact expanded when numerous universities throughout Europe-wide developing countries established research programs que studied applications de Abundio's principles at different local contexts, testing variations de vertical thermal architecture, using local materials ranging desde earth construction in Africa a bamboo systems in Asia, donde different materials y traditional techniques could be adapted using same basic principles, the thermal mass, convection optimization, y passive solar orientation que had proven so effective in Abundio's stone tower, pero que could be modified para completely different construction materials y cultural traditions, whilst maintaining essential thermal performance characteristics que provided superior habitability compared to conventional construction approaches que did not incorporate systematic attention to passive thermal efficiency. Optimization during design and construction phases. International development organizations had begun pilot projects in multiple countries onde rural communities lacked access to affordable heating systems, pero possessed traditional building skills y local materials que could be utilized para construction de improved housing, que incorporated thermal efficiency innovations based on principles que Abundio had demonstrated successfully in su specific Spanish mountain context, pero que proved adaptable a wide variety de different climatic y cultural conditions. When fundamental principles were understood y applied creatively usando whatever local resources y traditional knowledge were available, rather que requiring expensive imported materials, a specialized technical expertise, que might not be accessible. A community's on improved housing was most critically needed para health, economic security, y climate resilience durante increasingly challenging weather conditions que were affecting rural populations disproportionately throughout regions. Unconventional housing was inadequate para protection desde extreme temperaturas y weather events. Párrafo 10. En octubre de 2024, exactamente 5 años después de que Abundio completara su revolutionary torre de piedra, su proyecto había evolucionado desde experiment personal hacia modelo internationally recognized de Sustainable Architecture Innovation, que había inspired más que 40 documented implementations en 15 países He had contributed a development de new approaches, a climate-resilient housing, emphasized local materials, traditional skills, innovative applications, the natural thermal processes, could provide superior habitability, compared to conventional construction methods, whilst remaining economically accessible to rural communities, needed effective alternatives, expensive commercial systems were beyond economic reach. The populations faced greatest challenges due to climate change, energy poverty, housing inadequacy, and regions on the traditional solutions were proving insufficient para contemporary environmental and economic pressures. Cumulative impact de su work had been documented in multiple academic studies, confirmed economic benefits totaling hundreds to thousands of euros and reduced heating costs across all documented implementations, environmental benefits equivalent a preventing consumption de massive amounts de fossil fuels would have been required para achieving similar thermal comfort using conventional heating systems. Social benefits included enhanced community resilience durante extreme weather, increased confidence in local problem-solving capabilities, preservation to traditional building knowledge might otherwise be lost, como rural communities abandoned traditional techniques and favor the expensive commercial alternatives often proved inadequate para their specific needs and constraints. Recognition de Abundio's achievements culminated cuando Nobel Committee para Economic Sciences cited his work como example de indigenous innovation que demonstrates how local knowledge combined con systematic experimentation can produce solutions que are simultaneously more effective and more sustainable que conventional approaches developed a través de formal institutional research. Acknowledging his practical innovations had contributed to understanding de how communities could develop their own responses, climate challenges using available resources, why traditional knowledge, rather depending exclusively in expensive technologies developed in different contexts, might not be appropriate para their specific conditions and needs. Durante final celebration de 2024, held in completed tower surrounded por landscape, had been transformed, not only por physical presence, the unusual structure, sino también por recognition throughout region, innovative approaches, traditional problems could emerge, desde individual creativity combined con persistence y deep understanding the local conditions y available resources. Abundio reflected an extraordinary journey que had begun con simple frustration sobre heating inadequacy in conventional house, yet evolved toward global recognition, the principles que could contribute a solutions para housing challenges que affected millions of people throughout world who needed better alternatives. Conventional construction methods que were failing to provide adequate protection desde increasingly extreme climate conditions, whilst remaining affordable para communities que possessed traditional knowledge and local materials, pero lacked access to expensive commercial technologies que might not be sustainable or appropriate para their long-term needs. Cuando decidí construir esta torre instead de conventional house, simplemente quería crear warm, comfortable home para mi family usando skills y materials que I knew were available in my own community. He explained durante keynote address que was translated simultaneously hacia multiple languages para international audience que had traveled desde throughout world to study his techniques. But I've learned que when practical innovation really addresses fundamental human needs, it naturally spreads to other communities que face similar challenges. Before long, simple idea que started con one person's determination to solve their own problem can contribute to solutions que help people throughout world create better lives using whatever resources and knowledge they have available in his own local communities. Fonte de